So sorry if I, for the people watching the recording, if they missed the introduction I was giving for Juha, but he's a person with a lot of experience in the field, with over 90 publications and experience building, to designing and implementing domain-specific languages for over 20 years. And he has done that, I mean, after doing the initial work as part of a research project, he has been part of MetaCase, the company behind the MetaEdit Plus tool for a long time. And so a lot of his experience with this specific tool. And today we are going to discuss a topic that I think is very important in our field because we all hear about, about anecdotal evidence. Maybe that is a too difficult word for me in English. Anecdotal evidence about the benefits of domain-specific languages. But today, Juha is sharing with us some hard numbers so that we can actually present, more concrete selling point for domain-specific languages. And I think this can be something that could help promoting DSLs even more. So it's time for me to shut up. Thanks again, Juha, and let him take over.
Thank you. May I share my screen?
Yes, sorry, I now have authorized that.
So welcome everybody to this session. And it's a pleasure to be here, and especially with the community of people who create the languages to share the ideas and thoughts. So feel free to interrupt me at any point of time if you have a question, or just use the chat tool. But basically, there are many kind of domain-specific languages, and they all share the same question, that how we can show that the language provides some benefits for the users. I'm personally an external DSL guy. But even if you apply internal DSLs, you share the same question that it is in this title, how you show to your colleagues that it makes sense to use your DSL. Especially if it's the case of internal DSL, the person can still rely on the host language and neglect all the abstractions that you provide with the DSL. So even for internal DSLs, this kind of question makes sense in my opinion. As Federico mentioned, I have been doing this kind of work for some time already, and shortly the background is that there is 10 PhD students in the local university in Finland who basically founded the company. And then we have been doing this. We didn't know then that it's a domain-specific language, but we learned by customers. And I have also academic interest, and I like to use an advert here that if you are interested in publishing papers, there is a special issue coming on Journal of Computer Languages on practical aspects of domain-specific languages. So all submissions would be welcome if you are interested in this kind of thing. For me, this kind of publication thing is a little bit hobby. I'm an adjunct professor, and this is what I do at leisure time. So a little bit about the background. Just one slide about about our company and what we do. We basically provide a tooling. It's called MetaEdit Plus, but it has basically DSL that the customer makes. But some specific aspects of this approach that we are using is that it's a collaborative modeling. So multiple people can edit the designs at the same time, like matrices, tables, trees, or diagrams as illustrated here. So it could be that Federico is editing this stop state and I would be editing this running state at the same time in the same diagram. And another aspect related to this is that we are using a repository. So we are not a file-based approach. So repository gives the additional issue of being able to scale to large designs. So you may have hundreds of thousands design elements, and that works then nicely. And of course, all the models that we have here based on the meta model. And this brings the second part of the tooling, where we have a tool for the expert who defines the DSL for the others. And on this language definition part, there are also some specific aspects here. The first, maybe most interesting, is that I guess you would call today this tool as low-code language workbench. You don't need to be programming expert to build your own domain-specific language, because you basically create your language by drawing the meta model or grammar graphically or filling these forms, drawing your symbols, and then you have the editor. And the language, another aspect is that because we are using repository also for languages, we keep the languages integrated, language definition integrated. So if you are aware of OMG stack of defining languages with MOF and OCL and QVT and some symbols, they are all kept separate. So we try to make them together. So if you change the meta model with, let's say here with the state has a different state name, and you change this, also the constraint that the state names must be unique updates automatically, as well as the notation that the state name is shown here updates automatically, and the existing models update automatically. So we try to reduce the effort to creating languages. And then the language definition part is also collaborative. So multiple people can create the language in the same repository at the same time. So it's quite typical that someone defines the grammar and others are making generators based on that grammar at the same time. So these are the specific aspects on our side. And of course, because this is a commercial tool, we need to sell this. And we need to have some arguments why you should apply this kind of tooling. And then it comes to the question that how we show this, that this approach somehow makes sense for the company. And this is the topic today, and mostly about the productivity aspect. And I also explain why we think that the productivity aspect is maybe the most important ones. We have tried others as well. And then I showed 3 cases that are all in practice done cases. So a little bit about the background, that if we show that let's create a language that this makes your life somehow better, the question is that how we can measure that the life is better if we use the DSL. And there are multiple ways to do that. Some are picking up the poor ways, like lines of code, which obviously don't work if you have a, let's say, graphical DSL. Or maybe you are looking that can I implement the same system with the same amount of function points or other metrics by using the old language and the DSL? Or maybe I'm calculating how many clicks I need to do in the interface to get the work done, or drags and drops and whatever are the user interactions. Or maybe we are just asking opinions. Or there are some studies which do it so that does the language allow me to complete the task? Or maybe can it allow me to complete the task so that I have minimum number of errors or no errors ideally there? All these have been successful or applied and showed also in academic publications. But what we have learned is basically the productivity aspect and measurement in terms of development time. So if we use a domain-specific language, can it somehow decrease the development time? So in other words, decrease the costs or improves the speed. And the time is a good thing as a measurement unit because it works very well over different languages. And it's also a good proxy for costs because management and everybody understands time and it can be converted to the money. And companies are using also it for budgeting and project planning and everything else. So it's not so complex to calculate if we would, for example, compare it that how many clicks we need to do in the user interface. Even though that might be important, but still the development time is what we have seen the most practical thing. Everybody can understand it. But still in the practice is that when we then ask companies to do these kind of evaluations, they don't do it, or very rarely, because there are high costs or the management doesn't want to put extra resources to do it, especially when many public research papers has a research methods that are very expensive for companies to conduct. So you need to have a different research groups, large number of developers, you need to repeat it, and so on. So you don't normally find these kind of studies at all. And those of you who really want to look how to do this kind of empirical study, the only one that I have found which shows statistically significant results with over 100 tasks, with focus groups, and especially well done is the paper on software engineering experiment, where they apply in the telecom area a DSL, textual DSL, for a message design. So that is the best one what I have found. But we don't normally have, or the customers don't have such resources to conduct the studies. Rather, they do limited studies, collect colleagues' experiences or opinions, but they are usually very subjective. But luckily, some companies try to do objective studies. And earlier this year, we were able to publish something for this company. It's a company in Finland, and you can see here the type of applications they are building. Very basic enterprise applications that are running into the cloud. And what the company had done is that they have been developing their own language and their own generators. And they wanted to know that does this make sense? And in my opinion, an interesting case in this particular company is that they are a project house. Most of our customers, and I think that also most of the users of DSLs are those who do products. So they know that they need to build similar kind of things next year too. So it makes sense to invest in building languages. But this is a little bit extreme case in that respect that they are a project house. They build enterprise apps for Azure for their clients, but they don't know yet who is the client next January. And what they did is they did an experiment by building the same system twice. And in the area of development, they had the same requirements and the same customer who checked that the result, the produced system is correct, what they expect. And they did it first in the traditional way and then in the modeling way. So the traditional approach would be that they first start by defining the schema and produce the SQL. Then they implement the business logic with C# in Visual Studio. And then they make a JavaScript and HTML for the user interface so that you will see something like these kind of systems then running. And the other approach that they applied was then the model-based development, where they have built their own domain-specific modeling language, where they model basically the data, the logic, like all the operations, and also the user interface. But the user interface was not completely generated. All the data was there, but the fine-tuning of the user interface was done in SQL. So they generate the user interface and its definitions in SQL, in database as well. But when we proposed that, how about making this in a larger experiment among 20 developers, they said that no, we want to keep the costs minimum. One developer is doing this, only one guy. And then they said that let's do the modeling so that it doesn't influence the programmer, the programming logic so much, because if they would be programming it, they thought that then they would know somehow better what the system should look like for the modeling case. So if they would be modeling, they don't see the details, which they would see if they would start in the programming. And then they collected time, and this is what, well, you know all what JavaScript, C# and SQL like, but this is a portion of the DSL for modeling the sample system. So very basic entity relationship diagram, and if you would click some of these, you would have more details. And they also have here additional elements for states and user rights and things like that, but it was not allowed to show them. We were not allowed to show those elements of the language because they thought that they are somehow secret or give them competitive advantage. But I believe that in this community, nobody would see them particularly special. So one person make this kind of model and then generated the system that you saw earlier. And then they measured the time. And the evaluation showed something that the language and generator they have been building, they make software development 5 to 6 times faster. So building the system with the models took 1 hour and 15 minutes. And then the user interface, little about 2 hours. But for the database, they took 5.5 hours, business logic 12, and user interface 16. So this is the less than a day work, and then this is almost 2-week work. And the surprising difference was that the project setup was faster with existing tools than with the domain-specific language tools, because these were built internally, so most likely installations and configurations were not so smooth as they would be in ready commercial products. And obviously they were happy that the language worked there. But I think that what you are now saying is that yes, interesting results, but there was only one person, and maybe the application was small, even though it was typical, but it was small. How about if other persons would be building these? What if there would be other applications? What if there would be other kind of applications like these standard CRUD, create, read, update, delete database apps? What if there would be maintenance kind of things? So another company who addressed a little bit more these kind of things is a company that we are allowed to mention also. It's a company which makes sports computers. So if you are a sports guy, you may have some kind of these devices in your hand. This company is called Polar. They are for professional sports people, I think. And half of the code is different, and half of the code is the same, roughly. So the same code is something like battery management or measuring your heartbeat or things like that. But what the consumer sees in the screen, they change all the time. So this company make a DSL, and most likely this is not the one they are using now, but this is the latest. This is the only version we are allowed to show, but you get the idea that you have screens and you have views and you navigate in the screen. And based on this, then they generate the code for these handheld computers. And they did the same thing than the other company did, the first company. They asked one guy to build large portion of the system, and then they measured the time. But because they thought that it was only one guy, what they did is that, okay, we ask 6 other guys to build the same system, not the whole system, but something typical, a daily work kind of system by using the language. And among these 6 developers, 2 were new ones, less than 1 year working experience. And then they measured the time, that how long it took to build the system, and they noticed that it took about 75 minutes to 125 minutes, with a mean 105 minutes to do the task. And then they find out that compared to experiences on building it earlier, it was over 7 times faster with the DSL. But because this is a Western company, the opinions of developers rely also. So the person at Polar who conducted this, he also asked simple questions, that what is in your opinion in Likert scale, 1 to 5, 5 the best, that is the modeling language, how it reads the productivity compared to earlier approach, which was the earlier approach is programming in C. So the models are generating C. So rather than writing the code in C, they ask, well, is it more productive? What language helps them to prevent errors to happen? And also, interestingly, they thought that the generated code is better quality than what they write today, which was very interesting question, because normally in these kind of embedded devices, you have less memory, so the code must be good. But they thought that, well, based on their experience, the quality of the code is better. And this is, of course, opinion-based. The guys who are writing the code today manually, what they think about the quality of the code being generated from the models. And we were extremely pleased. Well, actually, they built a generator, but we were extremely pleased that in an area where you have less memory and less computing power, the quality of the generated code, they considered better. And also other aspects that management emphasizes that can people learn this? And if they recruit new people, it is easier for them to start and be productive. So when they measure this, they find out this kind of productivity differences in the 6 developer focus areas. But interestingly, if you look these kind of figures, you may ask that, yes, it's all programmers are using this language. But what if we take the larger spectrum, the whole life cycle of these systems? Because usually they start by having first concept design, that someone has an idea that how about the history of my sports activity working in this particular way, or my diving history, visibility, or something like that. And they didn't use this modeling language for that portion at all. Or how about if someone tries out different kind of usability, how many clicks you need to see when you see your sports history, kind of things. Or localization, because these devices, you show different kind of text for different people. So how they can see that the text fits for this tiny screen. There are own people who do that kind of thing. And of course, testing. So what if we have a DSL that is not anymore used by traditional developers, but it would be more used by the user interface, user experience people, user interface experience people, usability people, and localization people. So the range of potential users for the language would be larger. But we don't have any data for them on this. But I'm not saying that this is the only place they are using. Not only developers are using the same language, can be also used for others. So you could still say that nice, there were more people, but what if there would be different kind of people, like subject matter experts, not the C programmers like originally in this case. So it could be that the C programmers are still making the code in C for those parts that are not generated. But for those parts that are generated, maybe the user interface people, localization people, they can produce the code by generating it. And we have one
Can
case.
I ask you a question?
Yes, please.
By looking at this, I mean, one thing that I was thinking is that in this case, these are, of course, a small application, because I understand that as an experiment, a company doesn't want to build a project for 10 years and just for the sake of experiment. But I was thinking that we could expect it in a larger projects, the productivity ratio is even bigger because given you're faster with modeling, you may get away with a smaller team, and so you have less coordination cost if you want. Do you think it would be reasonable, or?
You mean less coordination for less people?
Yes.
I have a third case for such a thing where the language guides larger body of people to work together.
Can I throw in an anecdote that goes a little against that? I was at a wedding on Friday, and I was chatting with a developer I've known through the years, and he split his projects into two halves. Ones that are small enough to do with Mendix, and ones that aren't. And that often happens when you got sort of large models that you deal with. You end up with more and more edge cases, and so more and more times you have to step out of the modeling language or whatever you're using. So in my place it was always to do with frameworks. So frameworks are great for doing the things that frameworks do, but as soon as you want to step outside it, it becomes a burden rather than a blessing. And so the larger the project, the more times you normally have to step outside of a framework or a.
Indeed. And I would like to mention this company case one as a such case, because usually if you use a low-code environment, ready low-code environment, you basically do what that low-code language allows you to do. But this company number one, they build their own low-code environment. So they can decide what are the low-hanging fruits that they want to automate and which parts they leave to the manual programming. So the parts that with their DSL, they leave to automation is that the user interfaces, the database and all the database operations, basic database operations, and the usage rights and some of the state management, what you can do in which order, they are all generated. But if the customer has then a certain, let's say, certain reporting needs, that I would like to report these applications in a certain way, that you are then maintaining and making manually, and you don't build a DSL for that purpose. And they are using C#, and the C# has a nice aspect of partial class. So you can have a same class that you are partly generated and partly manually maintained. That's a property of C#. So their decision was that they make their own framework and they decide which parts they want to automate and which parts they want to do manually. So it's they control. But if you are using existing low-code environments, the tool vendors put you the control. So then you are doing, let's say you mentioned Mendix, then you are doing everything what you can do in a Mendix, and if you can't do anything with Mendix, that's it. In this case, the company may decide, okay, we want to extend this for some reason, we want to extend this framework and the domain-specific language, because then we can cover more cases. But it is their freedom to choose. Plus, they can say to their customers that you are not tied to running this in the platforms where, let's say, Mendix allows to run it. You may move it to other cloud environments. So it gives you more control if that's what you need.
I mean, my point was more about the impact of size and whether that's something that you see. I think that was also Federico's point. I can speak for Federico. That do you see that the bigger the projects, the more benefit you have? Because obviously it's very hard to show that with these small studies.
Mm-hmm.
Is it something that expounds on itself, something that gets better as you get bigger project, or is it something where the scale actually is it reduces the benefits?
Yes. Okay, so I understand the size is now that how large the system basically is that you build. Yeah. Obviously, it could be that let's say that the tool that you are using is such that if you have more than 10,000 lines, then it starts to be slow. you surely can have that kind of things, but ideally, if you can raise the abstraction, you have less concepts, and then it should be ideally scale better to large.
Sorry, I'll carry on down the size of the project, as in the size of whether you measure it by function points or whatever you're measuring it by, or the time to develop. I think one of the issues that you'll have is that the cost of measuring that will prevent the studies of it. Now, we had a talk from Jonathan about open rewrite, and he said that the things that were stopping people rewriting the code in Netflix is because of the cost of writing it. So they said, if you can just do that for us, it'll be fine. So how about if you're making the tools that people are making to write the DSLs, maybe instrumentation could be added into the tools to make it really easy for people to study the cost of a project over time. Just a thought. And yeah, just anyway.
Yeah, what we have done is we have done some generic generators that calculates like metrics at how large your designs are, but they are made in a very generic manner for people to estimate their sizes. So maybe in a real world, the better would be to estimate the domain-specific sizes, like how many in a let's say in the Polar device, that do you have user interface actions that require more than 5 clicks, or what are the user interface actions that are taking most time?
Thank you.
Do we have time for another question before letting you move forward?
I spotted one question there also about the graphical aspect. That could
yes, that was exactly the question, and I think you are the right person to answer that.
We are obviously biased because we provide a graphical, so I don't know how trustworthy my answers are, but the reason why we are focusing on graphical is basically twofold. One is historical, because 25 years ago or so, there was a big movement toward graphical user interfaces like Windows 3.0 and things like that, away from pure command line kind of thing. So we basically then wanted to focus on these graphical. And the other reason is that we are targeting, or we firmly believe that domain-specific languages give best power if they are given for those who would not be programmers. So there's this discussion about subject matter experts first. So if we can raise the abstraction and build languages for those who don't have a computing or software engineering background, like Excel users, the Excel users can do all miracles with the Excel. And quite often they don't know why they should use text, in terms of that you need to have declarations and definitions first and include and import and whatever kind of things. They are not familiar with those kind of approaches that compilers expect input to be given. But if it's somehow that they can see, like they make some designs in the PowerPoint, then maybe the domain-specific language should also look like what they feel natural for them. But obviously, if they feel that text is natural for them, then it should be text. No doubt on that.
Thank you.
So there was a question about how to unite things. And I have my best case of uniting things is a case where you unite, this is a real case where you unite 9 things together. And this is a case in the Austria, in automation systems for fish farms. So domain-specific language for fish farms. These systems have a hardware part, software part, and then they have external contractors who install and maintain these systems. And these systems require a lot of expertise from different disciplines. So someone must know how the feeders or monitoring or oxygen systems work, and also what kind of sensors and actuators and cabling must be there. And also what kind of schema we need to define for each system, like a pond, so that we know how the consumption of fish food or muddiness of the water or temperature or whatever has evolved. And then there is someone who must design the user interface for the fish farm owner controlling it over the iPad. And someone must design the communication network and security, and also know how much material would be needed when the people go with the boat and rowing and installs these. And what this company did is that they built a domain-specific language, which is a little bit like a map-based. It looks like a graphical, but actually location has information, important information here, because location is like it is in the real world, in the lake, sea or river, or some are also in land, because if you have small fishes, you don't want to put them in the real water. You have your own in-house place for the small fishes, and once they grow, you move them, and you need to maintain them. So you can see here the DSL here in the toolbar actually. So the DSL concepts are like a pond, and some of the ponds have aerators or feeders and things like that. And if they click this one, they can see what kind of, how the oxygen is made for the aerator and how much voltage it needs and so forth, which are domain specific for oxygen aerators in fish farms. and also other kind of things like water pH value or water levels, muddiness sensors, and all kinds of things. So the idea here is that the sales guy goes to the fish farm and asks that, well, how many ponds you have, where you want to have, how large they are, which want to have an automated feeder and which you go and do it manually, how you want to measure, which sensor it has, and so forth. But doesn't know necessarily anything more detail like how to do the cabling or wiring or how much voltage it needs. So then that person takes this model and others can then say that, oh, it needs a certain kind of lighting or cabling or whatever is needed. And multiple people can then edit this. And the particular nice thing is that they can run here tests, and then there's a button called X. I don't know why it's X, but if you click this X button, then it generates you the hardware mappings for the PLC environment, programmable logic environment, which they use in automation system. So then they generate the code and also the user interface and SQL. So they know what kind of SQL tables we need to have, depending on which kind of configuration we have, and also how the network is configured, and also documentation for the third party who do the installation. So they know what kind of device and networks are needed, where it get electricity and all the details. And they go so far that they even generate the stickers for the wiring closet. So when someone goes and rows in the boat, he can also put the sticker where the wire goes. So it's really model-based. And now if you consider this the opposite, that you would have different guys each maintaining their own portion manually, and how to keep other things related. So it's better quality control if you have a uniform DSL that not only handles the whole domain, but allows multiple people work in the same domain.
Can I ask you if this approach also helps with training and onboarding people? Because I would assume that, I mean, people are more guided in this process. So, for example, they don't need to learn what to print as a label for the closet, because the system does that for them and enforce some consistency.
Yeah, you may have that kind of guidance for the language users, so that when you are creating the models, it can show you that something is missing or not complete, that someone must enter. So this is a totally other example, but just to illustrate here, you describe here vulnerabilities in the cars. This is another DSL, but if I have something missing here, it will show you errors that I can't calculate the vulnerability scores because something is missing, and it shows you here that, oh, I must connect certain things somewhere, and only when I collect things, then things start to work. So you can provide that kind of guidance for the user as a part of your language definition, which is often neglected part of the tooling. They provide errors and things like that, but you could also provide guidance that, okay, what is missing? And they also measured here the productivity difference. So they built the same system, real system, twice, and then they compare it. And they found out that building a model that you saw earlier for a fish farm took two hours compared to writing the code, which took 16 hours. So they were 8 times faster with the modeling. And I should mention that they didn't compare it to situation where they would write the code from the scratch, but they compare it to the usual clone and own approach, where you copy the code of the previous fish farm or the closest fish farm, and then you start changing it. But the biggest savings in time actually came because they found out later that they had errors in this clone and own model, and they did the on-site installation by this third company who needed to do portion of the work twice because they had errors. So they need to go back to the switchboard to correct the errors and then redo some of the installation work. So this is a quality impact, but you can see it influences the time needed. But obviously the productivity ratio is not so high because the installation takes a lot of time. But of course, time-wise, this saves a lot of hours, man days, to do this way. But again, you could ask that, okay, nice figures, but how about if we need to maintain the same fish farm? Will it be then also faster? Or if we build it many systems, or even you could ask what is the effort to build the language in the first place before it pays it back? And usually project houses don't build the languages because they don't know yet whether the next project will be using this DSL. So what we have learned from this is that the effort in time can be collected relatively easily, and time is understood by everybody. And it's also good not only focus on producing the code or configuration, but if we can produce other kind of artifacts, then the value of DSL increases because we can use it more than just one purpose. And of course, the evaluation should be adapted to the current situation, not only who are the users, but maybe there are also people who want to read them. Like, can the guys who install the system, can they read the documents? And for us, even though I have a background of academic research, and I like that, companies are not interested in academic research. Good enough, if often enough for managers. So one company wanted to say us once in a hardware area that we collect 5 years data and then we decide. So after a year, I called and asked how the data has been looked like. And the manager said, we stopped collecting the data because it was so clear. But still the effort to build languages is one. And very few companies say publicly how much effort they have used to building the languages. But at least we have tried to keep the cost small. So usually it's something like 2 working weeks to build the DSLs that you saw here, and one generator. But obviously, if you add another generator and so forth, then it takes more and more time. So the development time, to summarize and have a time for questions or answer in the chat. So basically, I think, based on our experience, that even though there is a large body of things that we could measure, the development time is something that is simplest and best understood. And evaluations can be conducted in companies with modest investments. Even you can ask one guy to implement it. Of course, you shouldn't ask internship to do that. But if you can ask the guy who has been working long in the company to try it out, then better. And if the management is ready, then you can ask others to try it as well and collect all the data. And also, if possible, also consider the bigger scale of life cycle, covering also testing and maintenance phases. Quite often, DSLs only look, can I build the system from the scratch in the first place? But not about clone and own or other tasks. And it is always good to collect the data automatically, because then you can use it for later phases if needed. And especially for me, in person, collecting the data is close to my heart, because I made my PhD thesis 20 years ago on the topic of incremental language engineering with the idea that you cannot build the best language and succeed in the first place, but you can evaluate your language users with the data you have and then improve your language when you are going. So for example, if you have done it regularly, next month, I have a wonderful opportunity to inspect 300 modelers and look how they use the language, and then remove all those language concepts that nobody's using, for instance, and simplify the language. So try to collect the data, because then you can find out how to use it in a later and make your languages better. These are our experiences, but I'm more than happy, and actually I want to hear, and I also saw that you have many questions and comments, but also counter arguments and all experiences you have on measuring the productivity of DSLs. So any questions, or should I look these questions coming from the chat?
I think there is one question in the chat, and I see Michele was raising his hand in the video. I don't know if it was directed to us. So maybe we can take a look at the question in the chat from Peter and then go to Michele. And Peter was curious if you have considered looking also in this tile metaphor, and was providing the Blockly kind of UI as an example. Not very familiar with the concept, so I don't know if this tile metaphor is familiar to you, and if you have,
I am aware of Blockly and all these kind of languages. There are actually many of similar kind of languages, especially attractive with bright colors for children.
yes.
And by the way, we are using Smalltalk to build a meta-edit, which is also made for children originally. So there's nothing negative on addressing children.
I didn't know about this origin of Smalltalk, but
yeah, we don't have implemented such languages. They usually are kind of event-driven database modeling, event-driven state machine kind of languages. But we try to build the languages so that they look like in the real domains they try to address. So if it's for railway interlocking, the language should look like railway, for instance. Or if it's a fish farm, it should look like fish farm.
Okay, then I think Peter is showing it's okay with the answer. So maybe then we can go to Michele and then to Paul. So Michele, can you ask your question?
Yeah. Can you hear me?
Yes.
Yes.
Okay, perfect. Well, I find the study to be very interesting. However, from a methodological point of view, you have only 4 subsets, and that is hardly, let's say, a significant sample. So from a methodological point of view, I find it very inspirational, but I don't think that the numbers can really be trusted in terms of research validity.
Yeah. I mentioned the Kierpool study that Federico put here, link into the paper. So this paper is the most trustworthy, showing statistically significant results. And my point is that companies don't want to invest in making such a heavy experiments, and therefore they don't have a statistically proven, but the studies must show something that the managers and engineers can approve. So good enough is often valid for them. But I fully agree for you. If we would repeat, for example, the first case with other participants, it could give different results.
And also a double blind kind of test.
Yes.
Instead of using the same people for the same activities in different ways.
Of course. And different background people and so forth. But my point is that companies who have maybe 5 users or 10 users for the DSL, they are not ready to invest in such an effort.
Okay, thank you.
I guess we can go to Paul.
Hi. I think I just sort of missed a bit where you were talking about the more or less the ratio between the development of a DSL and the use of the DSL. So obviously, if we're seeing that the DSL is creating products much quicker, we'd hope that's the case, because that's why we create DSLs.
Yeah.
Now, in your experience, what at least with your tools, what would you say is the break-even point? How many new applications do you have to develop using a DSL before the development of DSL is worthwhile?
I think it depends on the domain. I put here a link for one ACM models papers for 2018, where we have 8 companies and they data on the development effort. So you have find companies like Panasonic or Porsche or Electrobit data there, what they have publicly said. But with our tooling, the effort is not large, but it could be that the reason is not in our tooling or not in the customer experience, but maybe they are building in DSLs in the area where they have a low-hanging fruits. So you build a language that handles large portion of patterns enough, so it already makes you faster.
All right, so you in essence, you bifurcate your code. You say, all right, we're writing code for this stuff that we know we're going to do a lot and do it over and over again. And then all the bits around the edge, we don't make that a part of our DSL. We make that something that we extend when we come to it.
Yeah. In the Panasonic paper that is referred there, I think they identified something like almost 18 patterns that they found out in the home automation software. And they implemented only 5 or 6 to the DSL, but they covered 80% of the code. So it didn't make sense to build a DSL for splash screen, for instance. So that's maybe the hard thing, to find out where is the balance, that which things it makes sense to build an effort to build a DSL and which you don't.
Yeah, so to summarize, find the things that you do a lot and then do a DSL for that.
Yeah, yes. And we think that therefore the particularly sweet spot is, for example, product line companies. You only express the variants, that how your products are different from each other. And then what is always the same and maybe just once installed, like battery management in Polar's watches. You don't build a DSL for that.
Okay, thank you.
And thanks for mentioning the worst practices paper that was written by my colleagues. They reviewed about 100 cases, or 70 to 100 cases.
I'm curious about this paper.
So finding the sweet spot and then showing the demonstration there quickly, then it will some concrete results to everybody. But if it takes like a half year or year to get your DSL, then many companies don't have a patience to invest so long.
Someone interested in domain-specific languages, I think it's nice that the worst improvement that you have shown was just 163% productivity gain. So, and I think it was the lowest. So, you know, probably it also means that even if measurements are not extremely precise, the advantage is so significant that maybe it makes an obvious case for adopting DSLs.
Yeah. Obviously, for the sake of finding the truth, I should say here that the cases that I report here and also in the paper are cases where the language creators have shown that their approaches are good. So if someone builds a language then and is happy, obviously that person wants to show that his language works and so forth. But I haven't seen papers which say that we build a DSL and now we are slower. Maybe they are, but I'm not aware of that. But it would be interesting to see that why. Is there something in the language, in the abstraction it provides, why that is the case?
I just wrote my thesis and did a survey on it, and people came back saying, yeah, we prefer the old textual language.
Yeah. And then most likely they were those who are maybe developers who have been using textual languages.
Exactly, yeah.
But then they have, the same people then have also problems if they're using like a cell-based languages like MPS, where you are not editing text at the end, but they think that it's not text.
Indeed, a story that will go back and forth in this community is how much of the textual dominance makes text dominant, and how much of it is our previous experience with text that prevent the more graphical, more projectional routes from gaining a foothold or gaining a larger foothold.
Yeah. Quite often, what we do is they have some PowerPoints where they draw things, or Visio where they draw things. One approach is then to build a DSL modeling language based on what they draw now in a Visio or PowerPoint. And then at least in the beginning, it looks like what they are doing now. But obviously, then you need to know that there are some rules here. And if you click an element, there you have details. Or maybe there's a submodel to describe the details with another DSL. But the beginning is what they have used to. And if your users are used to text, then it doesn't make sense to ask them to make a matrix or map or diagrams. Maybe they are very happy with the text.
So I wonder if there is someone with a final question. If not, I think it's time for us to thank all the participants, but to thank especially our speaker. I think for me it's always a great opportunity to learn from your experience and your practical experience building a lot of different languages for so many years in so many domains. And just want to say that one thing that I found very interesting among the many that you say is the short time that it takes for you to develop DSLs using MetaEdit Plus, because that's also, I think, an important point to consider, that probably give a significant advantage and a significant selling point to try to build the DSLs, because if it doesn't take you 6 months to just try build these cells, then you can really give it a try and see for yourself if you also see these gain in productivity in your case.
Yeah, and if you have some hours of spare time, some evening, feel free to download our tooling and try it as well if you are interested in.
And of course, I think everyone can Google MetaCase, but just in case, do we have any link that is okay? Well, I can Google it for people and add the link in the chat. Yeah. And okay, so thank you again, and well, have a nice evening.
Thank you a lot. And if you have any questions or want to have more details about any of these cases, feel free to drop me an email or contact, or of course join the student the forum discussion there, and we can chat over there then.
Maybe one final thing that Sergio is reminding me that we will switch to daylight saving time. So that will add some confusion for the next meeting, and we will skip the meeting on the 1st of November because it's a national holiday. So end of the public announcement. Thanks again to everyone, and I hope to see you not next week, but in 2 weeks at this point. Thank you.
Thank you.
Thanks. Bye.
Bye-bye.
Bye-bye. Thanks a lot.
Bye.